So let's start. On Saturday, we have a test, and the test is going to be on networking. So it's going to be about the internet networks that we've done here. We talk about the Wi-Fi, cookie, things like this. And 3.2. 3.2 is data transmission. Okay, if you remember, we talked about the fullplex, simplex. And then we did the third one is the tool. When you send the data, we have sometimes we have a mistake and we need to fix it. We have the parity bit. Okay, so the test will be on 3.1, 3.2, 3.3, and I'm going to just do a little summary on the piece of paper here. We'll go big screen, and then we can write here. Cool. So, can you look in your notes? What is 3.1? 3.1, what is the topic? What was the topic for 3.1? 3.1 is network. Okay? And then 3.2, what was 3.2?
Transmission.
Was data transmission. Data transmission. And then 3.3, what was 3.3? It was about the error checking. Okay, so these are your three topics on your formative test. And so I'm going to go through each one of these. So let's first start with the idea of networking. And I'm just going to scroll over to the right, networking. Can you tell me what is a network?
When two or more computers are connected.
Correct. So basically, a network, the smallest network you can have is when you have two or more computers. You have a computer or a computer. This is called a peer-to-peer network. Okay? Now, what is the name of the smallest network that you can have? Like in a home, there's a special name of a network. Do you remember the acronym? What is a LAN? What is a LAN? Do you remember what a LAN is?
Oh, yeah.
Correct. So LAN stands for local area network. Now, let's draw a little picture. What does that look like? Local means it's in just a school or your home, like that. It's not too big. So what I like to do is when I'm studying, I just like to draw a picture. So I'm just going to draw a little home. So in my home, or maybe a little bit bigger, you have your school. Inside that would be a local area network. Cool. Now we have something bigger. What is the bigger than a LAN? Is a WAN. So these two terms we need to know. These are important, and we need to be able to tell the difference between the two of them. What does a WAN stand for? Yes. This is a wide area network. Okay, what is a wide area network? Yeah, a large geography or a large area And so this could be like a city or a country. Okay, it's just many, many lands. So if I have several lands connected, that's basically what we get is the internet, right? And so let's just quickly draw what that would look like. A city. So here's my city. There's a tower. Here's a city. If you have a city, the network inside the city is called a WAN. Okay, what is the key difference between that? Because usually they have on a test paper, what is the difference? Yeah. What is the difference between a LAN and a WAN?
One is a LAN is small area, and one is larger.
Yes. So what we can do, if we have to determine the key difference, is a LAN is a small area. And they say it geographical. While a WAN is a large area. What else is different? Tell me something else different. One is about the area. What else? Let's think about a WAN. Who owns a WAN? Does someone own the internet, for example? Who owns the internet? Who owns the internet? Does anyone own the internet?
No?
No. And so, how about a LAN? Can you buy a LAN?
Yes.
Yes.
LAN is
Usually a LAN is a privately owned. You can buy the router and the hardware, whereas WAN is usually rented. Let's write this down. This is a key thing that you have to remember between the two. Is a LAN usually you own. Okay. When you're studying, don't write too much. You just have to get the shangha. You just have to get the idea. Do you know how to simplify your notes? We just want to put everything into picture and idea. Don't need to write too much. So WAN is what?
WAN is
Yeah. So yeah, we can rent. Okay. Rent means ATM. Or you can also say public. That's good. Public. I don't know. 私人? What do you mean? Yeah. Personal. Private. Private and public. So when you're writing your idea, this is called a mind map. Okay, when we're studying, and we just make it into the small idea like that. Private. I will zoom in so private you can see. Now, what was the after that? Did we talk about the wires? Did we talk about the xian?
No, you only said that the connection can be.
Okay, and then right here we talked about what?
The web page.
Oh, the server?
Web server, web page.
Oh, right, we talked about the internet. Okay, so that's about the physical stuff. Now, then the next thing we talked about was the internet. So let's scroll down here. We have the internet. What is the internet? Yeah. Basically, what the internet is a whole bunch of connections of local area networks. If I have a whole bunch of local area networks and you connect them together, then we get the internet, right? This whole idea is like a big wide area network. Now, when we talk about the internet, sometimes they say it's www. What does www stand for? It stands for World Wide Web. Is this a LAN or a WAN? Is this a LAN or a WAN? It's a WAN because it's the whole world. It's that. Now, there's another word. You need to know the difference between www and internet. Is internet and www the same thing? What is the difference? Yeah. World means, oh, this is L. 我少一个 L. World Wide Web. What is the key difference between the World Wide Web and the internet? Are they the same thing? Is this Yanda? What is the key difference?
One is connection of computers.
Yeah, one is the hardware, because here you have like the wires and things like that, right? The infrastructure, right? So we have wires that connect the internet together. So the key difference is you need to know that the internet is the infrastructure. It's the hardware. Okay? Hardware slash infrastructure. Okay? So this is a key thing, is one is the 硬件, right? Hardware. Now, if I'm talking about the World Wide Web, what is the World Wide Web then? Yes, this is the software. And this software is like web pages. Now, web pages have a special code. Do you remember the code of web page? HT what? 不是 HTML. ML. This is the code for web page, and it's hypertext something language. What does M stand for? I forgot. But it's basically the software. Now, what is the key? Where is this saved to? Where are web pages connected to? Oh, yes, that's one example. We use web browsers to view web pages, but where are web pages option? Where are they saved? They're saved on what type of hardware? Yes, and web server are basically inside your LAN. You're going to have a big computer. Okay, you have a 电脑 right here. We call this a server. And a server is the same as a computer, but he can serve people. Maybe he gives you Microsoft Word. Maybe he gives you some photo places where you can save photos. And he also has the web pages. Okay? So this is web pages. We save him. So I'm going to just put a little save icon. We save the code onto a computer, okay, on the IngPan, on the hard drive. It's somewhere on the internet there, okay? And when you go onto the internet, you remember we have the IP address. Do you remember the IP address? What is IP? Do you remember what IP is?
Address.
Yeah. Every hardware has an IP address. For example, 192.168.2.1. It has an address. Each LAN, you're going to have an address. And on the internet, each web page has a domain name. And he's the same as an IP address where you can use your web browser. So let's talk about web browser now. So we're on the internet. We have this thing that looks like this. He has a little X here, and he says search. What is this? You can put in your URL, www.bankofchina.com, for example. What am I drawing? What kind of software is this? What is this called? Not a website. Well, it is a type of website, but what am I doing here? There's this little bar right here, and we have menu. We have some settings. What is this? What is the name of this software that can use to view the web page? Yes, this is called a web browser. What is a web browser? What is a web browser? What does he do? Like, we have, on the Apple computers, we have Safari. We have Microsoft Edge. There's a whole bunch of web browsers. Tell me, we need to be able to say 4 things that web browser does. 1, 2, 3, 4. Tell me 4 things. Look in your notes. What are 4 things that web browser does?
View web pages.
Okay. He converts the HTML code into pictures and images so we can watch. So one of his jobs is it decodes HTML code. So it makes it so we can see web pages. Very good. We need to give 3 more things. What can he do? He can store your history. In here, you can find out how many web pages you went. He can store your search history. We need to get 2 more. What else can he do? He can save web pages, bookmarks. This is to save web pages, web addresses. Tell me something else. He has a URL bar. So he has an address bar. And one that we should talk about is called a cookie. Tell me, what is a cookie? Yes. Now, there's 2 types of cookies on the web browser. Do you remember? Let's just go into here. Yes. What a cookie is like a bingan, right? And do you know why they call him bingan? What happens when you eat a cookie? When you grab a cookie with your hand, tell me, and you start chomping on the cookie, what is going to happen? We're going to lose some pieces. We're going to lose some pieces that are going to fall. This is called bread crumbs or cookie crumbs. And so this is the idea is, anytime you go on the internet, you always leave some data. That's why the hackers can find you, because they can look at your cookies, right? And web browsers will save cookies, and there's 2 types of cookies. One is called what? One is called session cookie. Tell me, what does a session cookie do? Or what does he say? Yeah, basically session cookie just saves some data when the web browser is open. It just saves the data when the browser is open. For example, the stuff in your shopping cart. The stuff in your Twitch, if you haven't logged into the web app or whatever, the stuff in here will be lost. But we have this other type of cookie that can save for longer. What is the name of the other cookie? The second one is called what is it called again? Persistent. This means it saves for a long time. Tell me an example. Yeah, like a password. What else? Your name, maybe. Name, maybe history. Yeah, things like that. Okay, so again, we're just talking about the internet. This whole thing is about networking. We went into that. That's the general idea. What else did we talk about? I think that's pretty much it. Wait, what is the second thing that we did? So the very first thing was about network. That's done. I'm just going to go up. We'll just check it out. Networking is done with that. We have to talk about data transmission. Okay? So let's talk about data transmission. I'm going to come over here. Okay. 3.2 data transmission. Now, when we connect to the computer, we usually use a wire, right? And we don't always have to use wire, Sometimes you use the wire, or other word is called cable. How else can you connect two computers together? Right. You can also use waves. There's basically two ideas. Now, that's called Wi-Fi. So cable, let's just quickly talk about the different, did we talk about the different types of cables? For the cables, what you can have is this internet cable. It's called Ethernet cable. It uses copper. It has the 线. Okay? We have copper. Do you know in physics the Cu? Do you know what Cu stands for in chemistry? You know Na, Ag. Ag is gold. Cu is copper. 是一个铁子. And so we can have copper cable. It has a little sheath, and then it has a copper wire, and then it looks like this. And basically, electrons can flow through the 线. This is Cu. This is a metal. 对不对? The other type we have is called fiber optic. Fiber optic. It uses the light it uses the light. It's the fastest. The idea what happens in this is you have a cable here and you shoot the light. And this is the most fast one. It uses plastic. But, so this is a plastic. It doesn't use copper. And it uses light. It has a high bandwidth. What is bandwidth? Bandwidth. Do you know what bandwidth is? Bandwidth is how many ones and zeros you send at one time. So this is 1, 0, 1, 0. This is bits. So bandwidth is the number of bits you can send in 1 second. And it's measured in bits per second. Okay? And so fiber optic has it's super fast. It's very fast. Okay? But the problem with the fiber optic is that you can't bend the wire. But those are basically cables. And then waves we have is like Wi-Fi. Wi-Fi, it uses the radio waves. And you can also use satellite. Okay, but basically you send the data. We're going to talk more about the CN. Now, how the data goes to a device and back, what is that called? There's different type of way to transmit. Let's talk about the wires. Do you remember about the wires? So in the wires, we can have one wire, or you can have multiple wires. So you can use one wire, but inside the cable, you could actually have many, many wires. If I only have one wire, what is this? So one wire. Yes, this is called serial. And then if I have multiple wires, is what? It's called parallel. Which one is faster? Parallel is faster, but he has some problems. So let's just zoom in here and find out why. What's going on with this, with these wires here. So parallel is fastest. This is slower. Okay. Why do we use serial, even though parallel is faster? We use parallel when we have like the CPU, and then we have RAM, right? Pair EL， 对，这就是 EL。Why? Okay. What is some problem with a parallel transmission? Do you remember the two problems?
Crosstalk.
Yes, because this, we can send the data here, but as those data go, he's going to make a magnetic field. Let me just put a different color. He's going to have induction. And those can add data or delete data on my other wire. Okay? So some key issues that you should know is, okay, it's faster, but we have this thing called crosstalk. Crosstalk, what is crosstalk is when bits on other on the other wire when the bits on the other line flip. So sometimes a 0 can become a 1, or a 1 can become a 0. This is called adding data, and this is called losing data. Okay? So you can induce some crosstalk. So this is not a very good thing. So this is one bad thing about parallel. If the wires are too close. Okay, tell me one more problem. Yeah? What is the other problem? Skew. Yes. Skewing of data. Now, what is skewing of data in your own words? Yeah, because as this means it's a 1. Let me put in blue. This means it's a 1 wave, right? And then this is 0, and this is a 1. They all start at the same time, but based on the different resistance, at the end, maybe this bit arrived this time, this one arrived this time, this one arrived this time. And we look, this is called skew. The bits don't arrive at the same time. So even though they're faster, we have to wait. Okay, we have to wait. This is a problem. So skewing, it just means, can you put in your own words, what is skew? Let's just write down what skew is. Correct. Skew is when bits arrive at different time. And this means that we have to wait. So this is the other problem. All right. So what is the most common serial port? We have this thing called ports, like a chatto. It looks like this on the back of your computer. This is the port. Tell me, on your computer, what is a serial port? The most famous one is called what? USB. It's called USB. So you need to know different port names. USB. USB stands for what? What is the... I'll give you a hint. What does the S stand for? This is universal. S stands for what? Nope. We have parallel and we have serial. We have serial port. It's called USB. USB. And what happens is we have a positive line, we have a TX and an RX, and we have ground. Right? The ground is fuhao. This is positive. And what happens is the ones and zeros can go one direction. And this one, this is the data can come back. This is the most common serial transmission is called a USB port. Okay?
Why is ports
Pardon me?
why is it going to serial ports? it's called USB.
Yeah, oh, Universal Serial Bus. 对 it's called bus, 不是 port. They may actually call it port too, but this should be bus. Yes, Universal Serial Bus. This is a plug and play where it's 方便, right? Where you have the mouse, keyboard, they're all USB. USB means it's universal. You know this chapel, right? It has the symbol. It has a symbol that kind of has the 线 that looks like something like this. This means like USB. But transmission can go there and back. And we're going to talk about the different type of transmission. So this, remember, you know USB port. Now, an example of parallel port. Did we talk about parallel port? What is an example of parallel port? Tell me something that uses parallel. Is your old printer. Back in the olden days, you had a port with a whole bunch of small pins, and this was a printer port. Okay, so your printer port was an old parallel port. Okay, this is an example of that. Okay, so this is like the old. This is old. We don't really use the parallel ports anymore, or printer port. Right now we use the USB, it has these. So we're gonna be talking about the type of data transmission. This is the key thing. Okay, let's zoom in here. What do you call when you can send data to and from like a road? We have different types of transmission. What do we call when you can send data to and from on the same road? What do you call this? We have 3 types of transmission. Number 1 is what? Do you remember, what is it called if you can send data 2 ways at the same 一样的时间? If you can send data to the device and away from the device at the same time, what is this called? Do you remember? Yeah, this is called full duplex. So if you can send data and receive data, this is called full duplex. Okay, if I can only send data one way, what is this called? This is called simplex. Means one way. And then the last one is you have one line, you can go both ways but only use one wire. What is this called? This is half duplex. Yes. So half duplex. USB is, what is USB? Simplex, fullplex, or half duplex?
USB is how to
USB is full duplex because full duplex means you can, it has 2 wires. We have 2 wires, we can send and receive at the same time. Okay, so let's just put this in the bracket here. What is the key thing about this is it has 2 wires, can send, we go TX, can send and receive. At same time. Okay? Fullplex is one wire and it's shared. Okay? We can send and receive on one wire, but we have to wait. Can send and receive, but must wait for the other transmission to send. Okay? Simplex can only go one way. So just remember this. This is still one wire, one way. This is two ways. You can send, receive at the same time. Same time we call it simultaneously. There's a
So TX means
transmit. Yeah. TX means to send. T stands for transmit. R stands for receive. This we should have an E. Receive.
so what is GND?
I before E.
Oh, I say EI.
EI?
Yeah,
EIVE?
no,
Oh.
I say EI.
RECEIVE. What was your question? I forgot.
GND.
Yeah, what is GND? Where's my ground? GND. GND stands for 符号. You know how you have a 点式? This is 加号, this is 符号. 符号 means ground. It means like the 地上, right? And this means positive. Positive. Okay? So the USB has four wire, you plug it, and it's called plug play. It's 方便. It's convenient. Blah, 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 blah. Okay, that's it for transmission. Cool? So let's go back to the very beginning. Data transmission. We talked about fullplex, duplex, all that. So we can give it a little check. Okay, last thing, and the last thing is about the toll. Because when you send data, sometimes my data don't come back, do they? Sometimes we have the errors in transmission. So this is the last thing that will be on the test. Because sometimes we have the problem. Number 3, we have error. Error. Okay. Tell me, what are some errors that we can have? Tell me, let's list all the errors that we can have. No. The error checking methods. We can add error, yes. But how do I know what is some checking methods? Identification of the toll. What is the first one? Yes, we have echo check. We have echo. What else do we have? Parity bits. We have check digit. And then we have check sums. And we have AQR. Okay, so you need to know these 5 different error methods. Okay, let's just talk about it. Echo. Tell me, what is echo?
Echo is computer
Yeah, basically you send the data, you know what an echo is? The sound comes back, sends to and back. So we just send, and then we wait for reply. We just send and then wait for a reply. This is the most simple one, right? Okay. Send and wait for reply. If you don't get you have a certain time, and if that time happened and you still haven't received it, then you'll know that the data didn't give. If you reply, it means it's okay. All right, done. Tell me, what is parity bit? There's two types of parity.
One is 0 and 5.
So parity bits are always at the front of my thing. We call this a parity bit. And there are two types. We have even and we have odd parity. You first want to identify who he is. What does even mean? Even means that the total number of bits should be 2, 4, 8, 10, something like that. Odd means 1, 3, 5, done, done. And so what happens is you have your data. This is called data. This is the package that you're sending, right? This is your data area. And this is your check bit. Check bit to see, or your parity bit to see if the data has received okay. When you first send the data, you're going to send an extra piece of data called the parity bit. And if it's even parity, the total number of bits sent plus the parity bit must be 1. So what you do is you count. We have 1, 2, 3, 4. If this is even parity, what is the parity bit?
0.
It's going to be 0 because it's even. The even number of bits sent plus that. Okay, so that's the idea. If it was odd, this is 1, 2, 3, 4. I'm going to have to add 1 to make it an odd number. That's the idea. Okay, pretty basic there. Now, check digits a little bit more difficult. We get a little bit harder, from easier to more difficult. Okay, so tell me, what is check digit? And tell me, where is it used? Yeah, check digit is used in barcodes. Barcodes. Is it? ISBNs? ISBN? It's like for books and things like that, for shopping, right? And what happens is they have a barcode and it has, oh no, it doesn't have binary. Why am I writing binary? It has some numbers, 2, 5, 6, 3, 4, right? And the barcode have these black lines. Each black line corresponds to a different number. Agree or disagree, right? And check digit uses an algorithm. Maybe the very first thing is we have a multiplier. Okay, I'm just going to zoom in so I can see more clear. Okay, let's just show right here. So in here we multiply. Maybe we have some standard numbers here. 2, 2, 2, 2, 2, 2, for example. And then we have the sum right here, right? You're gonna do this times this, then we get 4, we have 10, 12, 6, 8, and then right here we have the sum, right? So you just add this up, boop, 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 you get your total here. And then it uses mod. Mod means division of the remainder. And usually they use mod 10 or they can use mod 2. Okay? And so what do we got here? We have 14 plus 12 plus 6 plus 8. What do we got? 1, 2. We have 34. So if it's 34, and then we go 34 mod 10, what is the answer? The answer is going to be 4 because that's the remainder. And this method is a bit that we can check to see if the data is okay. So the key idea, the word is check bit uses uses an algorithm. Uses an algorithm to determine a number to see if the data is correct. If it's not, then usually it uses mod. Okay, so you just have to remember two words here. Algorithm is math, and usually the algorithm is a modulus. This is the division remainder. Cool.
So TFL or TFE
algorithm. Yeah. ALGORITHM. Can you see okay? Okay, second last one. What is checksums? It's a little bit different, but similar. What is checksums?
I still have a question. After we call 10 and we get it for how many?
So what happens is before the data is sent, the computer will do this algorithm and it will have this number. And so the data that they'll send, they'll have to send that, they'll have to redo the calculation. And the sender will know that 4 is the result. And then if he does it and we compare this to this on his computer and it doesn't match, then we know there's some problem.
So how computer to see the
He's going to have to, he'll have to compare, okay? So when you do this scan, he does the code, and if there's one of these numbers change, for example, if let's say he didn't scan correct and this number changed, it's going to change this. And so by comparing there'll be a test number, then we'll know. Okay, originally before you do the barcode, we do the 书写, and we already have this number. Okay, this number has to be shared with the other computer, and then we compare it with what the other computer do, and then we'll know if it's correct or not. Does that make sense? You have to share this one number. Either they'll send it later, or they'll send it with the data.
So like we use this number to do the calculation?
No, we do not do that. We use the data, the barcode data, to do calculation to get this number. Then later we compare it with the expected number. This is the expected result. If it's not the same, then we know there is a total. Now, whether this number is sent I think they may have a table already on the other computer, or they will send the table later, okay? I'm not 100% sure about the barcode, but usually you just go beep, beep, beep in the store, and they already have all the calculations already on the computer, and then it will say, oh, there's a mistake, okay? So sometimes they send the data, sometimes they could share the data between each other. Yeah. What is checksums?
I'm not sure. I'm from his IC.
Huh?
I'm not sure about this because yes, Tuesday I get my points deep
Oh,
when you teach this.
checksums is an idea where, let's say you're sending some data, 3, 2, 5. Checksums, we just add the numbers together. What do we get?
10.
We get 10. And this data will be sent with this data. So we send this data, this is the data, and we also send some sort of sum. Sometimes you add the digits together and you send that. And so if your sum is not the same, then we have a problem. Sometimes you send bytes of information. Maybe I have 1 data byte, 2 data byte, 3 data byte, and then at the header, I'm going to say I'm sending 3 bytes. This is the number of data that I'm sending. And this has bag of bits, that has bag of bits, right? And that has 8 as well. And so what the receiving computer will do is say, hey, you send me 3, but let's say one of the bytes got lost. Then he would say, hey, you sent, but the first guy said 3, but I only got 2. So what in the world's going on? That means we lost the whole byte. What is the problem with this idea? What is the problem with the sum? There's some problem. Is this idea reliable?
No.
Tell me some. Sometimes we may get the correct answer. Tell me some problem.
Maybe it's not the original number.
Yeah, because maybe I send 9 plus 1, right? And I get the same result. I'm gonna say it's okay, but it's not okay. It could happen. This problem too is if I send some data, I don't know where's the problem. Maybe, this way. Let's say I did receive the data, but one of the bits became 0, and I still receive 3. So I say it's okay, but 1 or 2 bits changed. And so even though I received the data, but maybe there's some hole in my data. So this also has some problem. So checksums can have hidden errors. Hidden errors where, maybe a bit change. Okay, maybe it just by luck we get the same number. And I think it's okay, but it's not okay. Yeah. That's called there's many different ways. This is the idea of adding. It's called sum, checksums. Right, last one. Now, the last one is AQR. What is AQR? Let me just zoom in. Yeah. AQR is mostly used by your shoji. AQR. And what happens is you send the data and then you have a specific time before you get a response. So, okay, AQR stands for automatic repeat query. Automatic repeat query. Query. ARQ. And basically how it works is you send the data. And then you wait. You're waiting a certain 时间, whatever that time is. Okay? After that time, we should expect to receive two things. Okay? Either you're going to get positive acknowledgement, that's A-OK, okay? Or you're going to receive a negative. Negative, it's not okay. Okay? And so the idea is basically, it's like the echo idea, but the key difference is there's a specific time. A wait, we call it a wait time or a knowledge time, a wait time, where he's expecting to receive a signal back of a positive acknowledge to say, hey, I received your thing. Now, or if I don't receive it at the right time, we have this thing called timeout. Timeout. Timeout means that it's a failed data. It's a fail. The data did not reach the other device. Okay? So it has a specific time in there that it's going to track. And if it didn't get it, it will get a negative. It will get a negative response, and it's a timeout. Okay? That means you can resend the data. Okay? That's it. Okay, we're going to take 5-minute break. Okay? And then after that, we're going to play our review game. Cool?